So using Pythagoras' theorem to solve two-dimensional problems. So basically in this one, it's just doing the Pythagoras stuff, but doing word problems to find solutions to them, I guess. Just like all of the other word problems before, except these ones are a lot easier than the equation ones. The difficulty with equation word problems is coming up with the equations and then having to solve them. The coming up with the equations is probably one of the hardest things that you can do when learning anything in Year 9 maths. The problems in the Pythagoras come down to drawing a triangle and labeling a triangle appropriately. I find that it's a lot easier because it's a lot more visual. Anyway, when applying Pythagoras' theorem, what we're going to do is we're going to identify and draw. This big word here is the most important one. Draw right-angled triangles that may help solve the problem. We're then going to label the sides with their lengths or with a letter, pronumeral, if the length is unknown. Typically the one that we're trying to find, but there might be a step in between that you need to do before you can find the other one. Use Pythagoras' theorem to solve for the unknown. Pretty standard. Solve the problem by making any further calculations and answering in words. Answering in words. Ooh. So when we answer in words, we actually have to answer what the question's asking us. How high is the thing? How much taller is this? How far away is this? And finally, check if your answer makes sense. You know, if you've got two buildings that are 50 meters and 75 meters, they're not going to be 1,000 kilometers apart. So just make sure they actually make sense. So, match the problem with the question in the diagram and then solve that problem using the diagram. Okay, that's example for question 1. I'm not actually going to do this because in example 2, it's pretty much exactly the same. Okay, except in this one, you actually have to match the thing. The easiest way to do it is to just match the numbers, okay? Look at the picture, look at the description, look at the answer, match the numbers together. Pretty much it. Now for the real example, so this is example 1 for questions 2 to 6. Now two skyscrapers are located 25 meters apart, and that's indicated by this number down here. Okay, and a cable links the top of the two buildings. Find the length of the cable if the buildings are 50 meters and 80 meters in height. So this one is 50 meters, this one is 80 meters, okay? So what we need to do is we need to come up with a triangle to work out what my missing value, or the cable length, is in this case. So I'm going to use a letter for the cable, and I think I'm going to use a C. C for cable, makes sense. Now I need to come up with a triangle. Now in this case, I could, work out all of these bits here and make a trapezium, but I don't want a trapezium. I can't deal with trapeziums, but you may notice that I can actually make a right-angled triangle with this part in here, like this. So here's my right-angled triangle there. So I could use that there. Now, if I wanted to do that, I need to work out what the dimensions are. Well, the dimensions of this one down here is the 25 meters, which is the same as down here, because it's always, the two buildings, because they're straight, they're always 25 meters apart. So this part in here is 25 meters. So what I'm going to do on the right, or on the left, I was right, is I'm going to draw another triangle. Okay, now this bottom bit, so the distance between the two is 25 meters, like that. We know the cable is the hypotenuse in this triangle here, like this. And we need to work out, well, what's this far side equal to over here? Well, I know that the building on the left is equal to 50 meters high, and I know the building on the right is equal to 80 meters high. So the question now becomes, well, how much taller is the right building than the left building? Well, doing some quick, simple maths, 80 minus 50 is equal to 30. So the difference, so this is basically where the first building stops, and this is where the second building stops. There's an extra 30 meters between the two buildings, like that. And so there we go, we get our right angle triangle. So what we can do then is we can now, in fact, solve for the length of the cable by using Pythagoras' theorem. So we're going to start off by writing our formula out. C squared is equal to A squared plus B squared. Now it's actually very convenient that my C is equal to C in this one, so I can just put it straight in. So the hypotenuse is equal to C. So C squared is equal to, now the two other sides, well in this case it's going to be 30 squared plus 25 squared. So 30 squared plus 25 squared, nice and easy. So C squared is equal to, now we're going to put this into our calculator, as is So we're going to do 30 times 30, or 30 squared, plus 25 squared, and that is equal to 1525. Okay, so that's what c squared is equal to. Now that seems like a really big number, and it's because it is, because we haven't done our last step, or our next step, which is then to do the square root. So if c squared is equal to 1525, then the opposite of c squared is to do the square root. So square root of 1525. Now, I'm just going to rewrite it up here. When we do these ones, it's probably best that we actually try and work out, well, what is the answer as a decimal or as a whole number, because we don't really have lengths of cables as an exact value or as a surd. So we're going to put 1525 into our calculator. So 1525, the square root of that, gives us 39 point, and we're going to round it to 2 decimal places in this case. If it doesn't say, I just usually pick 2 because I like 2. And we get 39.05 meters. So that means the length, so therefore, the length of the cable is 39.05 meters long. Okay, so just a sentence to finish off that question. Okay, so what we did is we extracted the triangle out and made a little diagram ourselves. Okay, it's quite easy because we had the picture there to help us. And you might not be given the picture, as you'll see in the next example. And then we just solve it like that, and that's it. Okay, so once we do that, we're finished. So this is example 2 for questions 2 to 6. Okay, so let's solve the problems in this one. 2 flagpoles are located 4 meters apart. Okay. So, let's start drawing a picture. Here's a flagpole. Here's a flagpole. Okay. One is taller than the other. Okay, so one is 5.6 meters. And the other is 10 meters. Okay. And we know that they are 4 meters apart. So these 2 flagpoles are 4 meters apart. One's 5.6 meters tall and one's 10 meters tall. A wire links the tops of the flagpoles, and the length of the wire of the poles. Oh, and then we have to find out what that is. So this is a wire. Okay, so wire. So what letter could we use for wire? Well, we might use the letter W. Okay. Then we need to find the right angle triangle. Well, what I can do is I can move this 4 meters up. So I can keep going up, because remember, all the way up, it's all 4 meters long, until I get to the point where I get to the top of the first flagpole, 4 meters. Okay, so that's 4 meters there. Now, as you can see, I've got a right angle triangle here, because I've got 3 sides, including the wire, and the other side here. So what we need to know is, well, what's that leftover bit? So if the second flagpole is 10, and the first flagpole only goes up 5.6 meters, well, how much meters is left over for that second bit? Well, doing some simple maths, 10 minus 5.6 gives me 3.4. So 3.4 meters for that bit there. So now what I'm going to do is I'm actually going to redraw that triangle again over this side, just so I can sort of work out, all my stuff about it. And it's really important we draw this second triangle up, okay? Because later on in this topic, we're actually going to need to be doing this a lot more often so we can actually see a lot of things that are happening. So here it is here. Now I'm going to start off by writing out my Pythagoras theorem. So c squared is equal to a squared plus b squared. Okay. My hypotenuse is the side that's opposite the right angle. So in this case, it is the w. So w squared is equal to a squared. So it doesn't matter which side I use. I might use the 4. 4 squared plus 3.4 squared. So w squared is equal to, so I'm going to put that into my calculator. So I'm going to do 4 squared plus 3.4 squared, which is 27.56. Now, yes, again, that seems like a big number, but it's because we have found our, we've got it when it's the square. So now to get it just as the value itself, we're going to do the square root of 27.56. So square root of 27.56, we're going to put that into our calculator, and we're going to get it to 5.25 if I round it to 2 decimal places. And again, that number should be bigger than the other two because it is the longer side. And so that is my answer. But am I finished my question? No, I'm not. So I need to finish it off with words. So therefore, the wire between the flagpoles is 5.25 meters long. Okay. So you'll notice that that is the end. Okay. So this is not actually a big exercise. It's just practicing using some worded questions to solve the problems. So question 7 to 10 is extension. You do not have to complete this, however, but it might not be a bad idea to have a go. But with that being said, that's pretty much it for this one. Okay, it's a very quick one for today. And I will see you guys in the next video.